Dear students, in this video of mine, I'll teach you section formula for internal division. Before teaching section formula for internal division, one should know in what ratio a particular point divide a segment. For example, segment is AB, point P. In what ratio point P divides segment AB? You can see here. This is segment AB, A, B. In this case, point P, suppose point P is dividing segment AB internally. Internally means point P lies between A and B. So the ratio is what? Length AP upon PB. That means ratio is what? From first point of the segment to the point which divides upon the point which divides to the second point of the segment is the ratio. In internal division, there are two possibilities: numerator smaller, numerator larger. When numerator is smaller, P will be close to A compared to B, and when numerator is larger, P will be close to B compared to A, but P will lies it between A and B. In either of the cases, that is numerator smaller, numerator larger, ratio is what? AP upon PB only. And in external division, point P, see here, this is segment AB, and point P divides segment AB externally in the ratio. So point P will be outside segment AB. All the 3 points are collinear. In my diagram, it is just consider this. So ratio is what? Length AP upon length PB. So length AP is what? M, and PB is what? N. So here also it is AP upon PB. In this case, you are observing numerator is what? Larger than denominator. And second case, when numerator is smaller than denominator, in that case point P will be what? Outside segment AB, but P will be what? Near to A. So there also it is what? AP upon, see here, this is point P, this is A, this is B. So in this case also ratio is what? AP upon PB. AP is what? M, and PB is what? N. So before starting, you should know the ratio, in what ratio point P divides segment AB, either internal or external, numerator larger, numerator smaller. Now, if I'll ask in what ratio point L divides segment AB, so it will be AL upon LB. That is first point of the segment to the point which divides upon the point which divides to the second point of the segment is the ratio. So don't forget this. Most of the times when I ask students what is the ratio in which a point divides segment AB, they say M is to N. If suppose in problem it is given P is to Q, then your answer is always fixed, that is M is to N, which is wrong. So ratio is what? First point of the segment to the point which divides upon the point which divides to the second point of the segment is the ratio. So now students will start section formula for internal division. Section formula for internal division. Actually, these things are shifted to 10th standard, and in 10th standard they give direct formulae, and when you enter in 11th and 12th, your teacher says that this has already done in 10th standard, but 10th standard only had learned formulae. How the formula has come, you have not learned. So we'll be learning, so which will be useful for all of you. The statement is what? If A corresponds to x1 comma y1 and B corresponds to x2 comma y2 be the endpoints of segment AB. Let P x comma y divide segment AB internally in the ratio m is to n. Then prove that Pxy is equal to corresponds to mx2 plus nx1 upon m plus n, comma my2 plus ny1 upon m plus n. Hence find coordinates of midpoint of segment AB. That gives what midpoint formula. Proof. This is point A, x1 comma y1. This is point P, x comma y, which divides segment AB internally in the ratio. This is B x2 y2 internally in the ratio m is to n. So ratio is what? Length AP is m and length PB is what? N. Now from point A, draw AA1. From point P, draw PP1, and from point B, draw BB1 perpendiculars on x-axis. This is x-axis. This is origin. And this is your y-axis. So by definition, length OA1 will be what? x1, which is x coordinate of point A. Length OP1 is what? X, which is x coordinate of point P. And length OB1 is what? x2, which is x coordinate of point B. Now, students, later on we need two similar triangles in such a way so that one triangle has one side as what? M, that is length AP, and other triangle has one side as what? PB. So what we will do, from point, one triangle has one side as what? 1 minute. Hmm. So to get one triangle has one side as what? AP, from A we will draw perpendicular on PP1 and we'll name this point as what? R. So AR perpendicular PP1, and from point P draw PS perpendicular BB1. Okay. So length A1 P1 is what? Length A1 P1 will be x minus x1. So if length A1 P1 is x minus x1, so length AR will be what? X minus x1. Length P1 B1 is what? X2 minus x. The reason is what? Length OP1 is what? X, and length OB1 is what? X2. So length P1 will be what? X2 minus x1. So if length P1 B1 is x2 minus x1, length PS will be what? X2 minus x. X it is. Sorry. It is x2 minus x. X2 minus x. Now we'll start proof. Let A corresponds to x1 y1 and B corresponds to x2 y2 be endpoints of segment AB. Let P xy divide segment AB internally in the ratio m is to n. That is, length AP upon length PB is what? M by n. Write this as equation number 1. Draw AA1, PP1, draw AA1, PP1 and BB1 perpendiculars on x-axis. Therefore, we get, now from origin, length OA1 will be what? X1. Length OP1 will be what? X. And length OB1 is what? You have to remember which two triangles we have to select. According to that, we'll take betweenness. We want triangle ARP. For that, we require length AR. Since O dash A1 dash P1, again same thing as I told in my last video lecture, points are collinear, A1 lies between O and P1. Therefore, length OA1 plus length A1 P1 is equal to length OP1. Therefore, x1 plus length A1 P1 is equal to x. So length A1 P1 will be what? X minus x1. Similarly, O dash P1 dash B1. Now we are taking second betweenness. So here length OP1 plus length P1 B1 is equal to length OB1. Now length OP1 is what? X plus length P1 B1 is equal to x2. So length P1 B1 is what? Length P1 B1 is equal to x2 minus x.